So this is another example of a SimPy simulation project that was conducted with a rather simple SimPy based discrete event simulation template from the SCDA shop, and in this case it was a plywood warehouse where plywood packages were produced in a manufacturing area and then prepared for shipment in a shipping warehouse. All operations in this warehouse were by a forklift. So you can see here a rendered image from an exemplary animation for this project, and there were a total of 6 shipping gates or truck gates, all for outbound shipping, so to say. And there's an operation with regards to putting away the plywood packs here in the warehouse, and of course a outbound oriented retrieval operation where forklifts are retrieving relevant stacks from the warehouse and then load them into the trucks. So each stack is basically might be a different product configuration and is also assigned to a different customer, and there might be several packs here that are assigned to the same shipment. The simulation was then about basically simulating the utilization of the transporter pool for this put away and retrieval operation, considering the warehouse dimensions and considering 2 alternate warehouse operations. So the first type of warehouse operation would be to simply put away the plywood pack, a plywood stack somewhere randomly in the warehouse. And the second type of warehouse operation would be to divide the warehouse into a total of 8 zones, and to then assign plywood stacks that were basically assigned to shipments to one of these zones based on the forecasted storage time of this respective plywood stack. So for a shipment that would be in the near-term future, you would use one of the zones next to the shipping area, and if it is a plywood stack that will be shipped in a long time from now, you would use one of the storage zones more far away from the shipping area. These 2 alternate operations were then simulated using a SimPy simulation model, and this model has also been made available on my blog in the shop section, the SCDA shop, and it's another very simple example where I have a data models file where I model the transporter pool, I model the storage area, and I model the storage slots. And then there's a configuration file that allows us to set certain parameters. There's a models file which implements the chaotic warehousing with no zones, and another model that implements the zone-based warehousing operation. And then there's an implementation of the simulation study itself here in the main Python file. So we can see the content here in the project, the config file, main file, data models, and models PI. If we start with data models, we can see there's a slots class, there's a storage class, there's a class for modeling the jobs themselves, there's a transporters class which is used for modeling the in this case the forklift pools. Then there is a configuration file. This one is used to set parameters that can be changed to repeat simulation experiments. The parameters in this case are the number of put-away forklifts and the number of retrieval forklifts. So in this case there are 2 different forklift transporter pools, one for put-away operations and one for retrieval operations. Then there are parameters that refer to the simulated job throughput, or the interval time between jobs that are released in the simulation model. And with regards to each plywood stack that is being stored, there's also a random distribution for the storage time that is assumed in the simulation. For this, these two parameters, dwell time mean and dwell time sigma, are used to model the normal distribution of the storage times of the plywood stacks. Then there is a parameter that allows us to set the speed, which we can, for example, set to 5 meters per second. And then there's a parameter for modeling the interchange time. This is the time that is consumed in the simulation model for picking up a pallet in the warehouse, or for placing a pallet, for example, in the truck, or placing a pallet in the warehouse. So once the forklift has arrived at the target coordinates, this is the additional time that is consumed in the simulation model for placing the pallet or for picking the pallet. Then there is a list here that contains the, in this case, various storage areas. In this case, we have a total of I think 16 storage areas. So we can leave it at that, but in the simulation study itself, the final result was 8 storage areas. In this case, we can keep it at 16. And then there are parameters here that allow you to specify the position of basically the production source of the plywood stacks. So this would be the reference point of the put away operation start point. That would basically be the manufacturing line that outputs the plywood stacks. And there's a reference point for the retrieval for the destination of the retrieval operation. So this would be the mean truck location that is being loaded. So that is in that essence the parameterization and also the level of granularity in this simulation. Then the models themselves. I implemented 2 example models. So there's a superclass that all models use. And then you can see there's a non-zoned model and there's a zoned model. And these are the 2 models that are compared in the simulation study. The simulation study is then implemented in the main Python file, which I open here. And so you can see first I instantiate the non-zoned model and I then run it for a certain amount of time, and I output relevant statistics. So in this case, for example, the statistics are the simulated throughput, the average utilization of the storage areas by storage area, the utilization of the put away and retrieval transporter pool, and the average minimum maximum cycle time by transporter pool. That is what is being measured as statistics and outputted here. After that, I instantiate the zoned model and run it, and then output the results for that. And some exemplary results. If we look at the stacks, so we can, for example, look here at this exemplary comparison of 4 simulation runs that were ran with varying fill degrees of the varying degrees of storage utilization. The idea here is to see how the impact of zoning versus non-zoning changes depending on the fill degree of the warehouse. And in this case, based on the zoning logic, the difference is very large when the warehouse is empty, but also when the warehouse is almost full, there's still a significant difference in the average move time per forklift. And in general, we can see here that the forklift has a significantly shorter move time when using a zoned warehouse operation that's basically based on fast versus slow mover zones. And again, the fast movers, they are stored, placed in the warehouse next to the shipping area, and the slow movers, which have a longer storage time, they will be put away with a longer distance away from the truck, so that the outbound truck area. So this was the example model that was used for the simulation study. It was customized as there were some more detailed constraints and assumptions that were implemented in this model, but basically the template that I made available here in the SCDA shop is what was used for the simulation study. And it can be used for also implementing other aspects, like for example double cycling versus single cycling, and other operational aspects to see the impact on transporter utilization on maximum achievable throughput at the warehouse.